Hello everyone, I am Parth Sarthi. In this video, I am gonna say about OSPF routing protocol. OSPF, also known as Open Shortest Path First, is a widely used interior gateway protocol designed for routing within an autonomous system. It is a linked state protocol, which means it builds a complete map of network and uses the map to compute the best paths to each destination. It is based on shortest path first algorithm. Selects the path based on link metrics like link type and link quality. There are many routing protocols like RIP and BGP, but there are certain features for OSPF that set apart from these routing protocols. These features include like no hop limit. Like if you take a RIP, it has a hop limit of 15. But in OSPF, there is no hop limit, and you can include as many as intermediate nodes when required. In general, OSPF is designed to work within a single autonomous system. It uses complex algorithm like Dijkstra to find the best shortest path and updates its routing table when there is a change in the routing map. Administrative distance of OSPF is less compared to RIP. Uh, if you take RIP, it is 120, and for OSPF, it is 110. So when administrative distance is compared to find the best path, OSPF stands better than RIP. And even OSPF supports IPv6 protocol, and even it has a faster convergence than RIP. OSPF has three sets of routing tables that shows the best path between source and destination node. It has three tables like a neighboring table that has the list of directly connected neighbors. Followed by it has a database table. It contains all possible routes between the current node and to all the possible other routers. And the third one is the routing table. This contains the best path between the present router and all other possible routers in the network. So using these routing tables, uh, the router finds the best path to send the packet uh, to decrease the latency and other possible metrics. In RIP protocol, when there is a change in network topology or when a neighboring node is down, the routing information is updated using some update timers. But this update timer updates every 30 seconds and cause some congestion and overuse of CPU. So to avoid this in OSPF, there are it is a seven-step protocol to update the routing information when a node gets down. These seven protocols include down state, init state, two-way state, extract state, and exchange state, loading state, and full state. These seven states are used to update the routing table when there is a change in routing topology when a neighboring node gets down. The first state is a down state. Initially, the routing table is empty. So first, a node sends the hello packet to all its neighboring nodes. Uh, this process is called link state advertising. So later, this hello package will be received by all its neighboring nodes. This state is called a init state. So after receiving a hello packet, the neighbor sends an acknowledgement to the sender. So later it is called a two-way state. In the two-way state, uh, both the nodes communicate with each other after receiving the acknowledgement. After receiving the acknowledgement, the both the nodes start to negotiate to become master and the other as a slave node. They use different parameters like IP address to choose one as the master and other as a slave. The one with the highest IP address becomes the master, and the other node becomes the slave. This complete process takes place in X start state. So later, in exchange state, after negotiation is over, and they start exchanging the database description packets. This packet includes all the database uh, list of paths in its database to the new node. After receiving the database descriptor packet, it goes into a state called loading state. Here, the comparison of all entries takes place in the new router, and the actual exchange of linked state information occurs between these two routers. So here, they exchange all possible routes, uh, all the possible routes stored within in their database. After exchanging information in their databases, uh, the routers goes into a state called full state. Here, a full synchronization of all the information takes place. Uh, all the OSPF routing can begin only after this full state. So in this way, the updation of routing table takes place when a node gets down in the network. The main advantage of using OSPF over other protocols is it has no limit on hop count. So if you take RIP, it has a limit of 15 hop counts, uh, whereas in OSPF there is no hop count, so you can add as many as intermediate routers when required. And also the scalability stands apart it from RIP. In RIP, it is so hard to add a new router or a network in an autonomous system, and even the configuration should be done manually in an RIP. Whereas if you take OSPF, it has an inbuilt dynamic configuration, and also OSPF support both IPv4 and IPv6 network architectures. And including that, OSPF ensures the network remain free of routing loops. Also, the fast convergence of OSPF, which can quickly respond to network changes and update routers and routing tables, stands it apart from RIP and even BGP protocol. So, in this way, OSPF uh, helps in routing packets from a source to destination in a network.